Here is an update of the MATLAB script and get to kind of summarize what needs to get done before Monday night in as far as the test report. So the script, I'll go over it again. It pretty much generates everything that Finley defined that we would want to look at as far as, for the first flight. The section number, there were 16 for the first flight. You'll have to copy and paste this table down below for flight 2, and then flight 3. Flight 3 is the crash flight. And we get our average values for angle of attack, throttle, all that's calculated. Here's the variable name for it in MATLAB. Standard deviations as well. And the end results, the theoretical coefficient of lift, the theoretical coefficient of drag, the real lift, real coefficient of drag. And yeah, average values in this pink purple section and standard deviations in this blue section. And I'll go ahead and go over the test report stuff. So as the data analysis team, we need to do the technical discussion and the results discussion. So these boxes and these paragraphs in italics are from another flight testing class that some of us are in, especially as Southern Maryland students. And these kind of spell out what is expected in these sections. We think the Southern Maryland students, we kind of agreed that this is a really good template to use to end up with a really nice document in the end. So the technical discussion is pretty involved. So maybe 2 or 3 of you guys could be a part of that and getting that written. It shouldn't be too bad if there's that many people working on it. And I actually included, this is in the folder. This is a technical discussion I did for that class. This is for a helicopter, so none of this is really applicable, but it's just like the idea of what the thought process is for writing it. That's why I went ahead and copied and pasted it out of my lab, so you can see what kind of the thought process is there. You can go back to your basic physics principles and talk about why we, you basically build from the ground up in the technical discussion to really show that we understand what's going on. So there's the 2 things that we need to do. We need to do technical discussion and results. And results is I think you're really gonna lean on the MATLAB script for that. We're really diving into plots and what are good flight instances to look at. And so to run the MATLAB script again, there is this way you can use load. Clay tacked that on, which was cool. I, for some reason, couldn't figure out how to get it to work. I've used that tool before at work, so I don't know why I couldn't get it to work, but I just commented it out. If you want to uncomment it, save and have it written that same way. But anyway, you can just pick one of these 3. I'm just going to click the first one. So it loads in all your variables, and you just click run, and it's going to make a large amount of plots. And you can pick and choose whichever one of these you want to use. I just went ahead and auto-generated all of them so that it was there. So you didn't get bogged down or slowed up needing a certain plot. These last 3 are coefficient of lift versus angle of attack, coefficient of drag, all of those 3, those are important. And then these are all for the individual clusters of steady level flight. So we got flight time and then the airspeed. And then if I like come down here, you got elevator angle in degrees versus flight time. And then it says which cluster it is. So and then like go down here, like, you know, this one's the drag in pounds. And here's the drag in pounds for another instance. So we might have to take a look at this one, number 2. That one looks really steady. But those are there for you to look at, to make conclusions with. And for purposes of writing, 10% off, 10% is shaved off of each end, each flight chunk, to kind of eliminate, you know, the variability of, you know, when the flight controller inputs were given, as far as, you know, maybe he started steering before he unclicked the steady flight button, and vice versa. So hopefully that's there to kind of chop that off and reduce that error. And so that's everything there with the MATLAB script. You can kind of dig through the plots and see what it spits out. Additionally, I'll show you in Mission Planner how to plot stuff in case there's something that you don't have through the MATLAB script that you want to plot, that you want to look at. So you can open up Mission Planner and toggle over to data flash logs, click review a log, and I need to go into folder. So we can just hit review this one, and you can go to, like, you know, RC out is the inputs from the controller. And so this is C4 is the throttle. I think C2 is the elevator deflection input, and then C3 is the throttle. So you can actually see the C3 throttle kind of decreasing because we start really high, and then we jump down to about 50%, and then jump down to about 33%. So you can kind of see that in the data. Yeah, let me make that clear. So throttle percentage, this is going to go from, like, let's put like a note. Maybe a better fit. So what I mean by that is, for flight 1, you know, let's say steady flight section 1 to 5, core is at 100% throttle. I don't know if you guys remember. I certainly remember because I was the one watching the velocity on the screen, but he would be flying at, you know, 35 meters per second for a few passes, and then he would fly at 30 meters per second for a few passes, and then it would bump down to, I don't know, 27, 28 meters per second for a few passes. So you should end up seeing kind of like chunks or sections where they're the same. I think all of this throttle percentage, mean throttle percentage, that's in MATLAB, that's available to you. And I think that is it for now, as far as everything that I want to kind of give to you guys. You guys can go ahead and get started.